Welcome, and thank you for attending today's presentation. Today we're going to look at an overview of scan-to-CAD inspection software, namely VX Inspect. My name is David Arena, and I work at GoEngineer on the scanning team. The VX Inspect module is integrated into VX Elements, Creaform's main software which works with all Creaform hardware. This module provides tools for dimensional inspection using an imported mesh file. The inspection sequence or plan is created by adding an alignment, creating geometric entities, deviation maps, snapshots, and more. Basic dimensions can be created and measured comparing the mesh to CAD or nominal mesh. Reports can be created from the inspection sequence and output to Microsoft Excel. So here we're looking at the home page of VX Elements, and you can see that the VX Inspect module is highlighted. This is where we import the mesh here on the left, and we import the reference here on the right, which is the CAD model. So we're going to go ahead and import the mesh and import the CAD. So the mesh is going to be the STL file, and the CAD is on the right. So we'll go ahead and start a new session. Now we can see that the data has been imported into the session, and that the CAD is the silver part down there towards the bottom of the screen, and the scan is floating in space, which is common. So I'm going to go ahead and minimize that. We don't have a scanner currently hooked up to this session. You can see here that the CAD and the origin are local to each other, which is normal, and the CAD again is floating in space. So this navigation area is where the inspection sequence is going to populate. We can show and hide the data as needed. And the first thing, kind of left to right, is the alignment and creating the entities needed for dimensions, angular dimensions, linear dimensions, etc., or diameters, depending on what kind of entity you create. So here we can add a dimension by adding a distance. And after we create the entities, we may want to create a color map. We may want to add entity annotations, show some deviation annotations, and take a few snapshots for the report, and ultimately create the report. Okay, so we're going to begin by creating an alignment. It's going to be a surface best fit alignment. We have some options here. We're going to do whole CAD, but as far as other options go, you can also say pick on CAD. So the difference is whole CAD is the entire CAD model to consider for the fitting analysis, and pick on CAD is a more of a selective thing where you can pick on features or faces to be considered during the fit. So we're going to say whole CAD, hit the alignment button, and now you can see that the scan has moved to the CAD. You can see a little bit of areas where the CAD is kind of sticking out of the scan. So we'll say OK to that. And you can see now the surface best fit is the active alignment in the alignment tree. Okay, so the next thing we might want to do is to create a color map to show the deviations from measured part to the CAD nominal. So we're going to go ahead and create a color map. I'm going to go ahead and hide the CAD. You can see now we have some color on the screen, and this is again the whole CAD versus, as shown before, the pick on CAD. So we're showing the color map for the whole CAD model. There's a color bar here. Basically, anything within tolerance currently is plus or minus 0.002 of an inch. And we can see up above here in the error distribution area, and about 60+% of the data is fitting within that tolerance of plus or minus 2 thou. Now, as I drag these bars, basically expanding the tolerance, you can see the tolerance growing. So I'm being a little bit more forgiving just to kind of show you how that works. And at some point, 100% of the data is going to fit within this band, whatever that value is. So it looks like when I get to about 100%, it looks like everything fits in within a little bit over 15 thousandths of an inch, plus or minus. So I'm going to go ahead and change that back to 2. Now I might want to edit that color map just to kind of show you some options we have. in the area distribution, so we can say edit color map, and currently it's a continuous gradation of color with the plus or minus 2000 in there. We can change that to discrete as well, and you can see incrementally we've got currently 9 positive divisions and 9 negative divisions in the color bar. And you can see that it divides that range of the 2000 incrementally with the numbers. So if we change that, we can change the number of divisions. So let's say we want 5, and again, it's going to divide that range accordingly, and the numbers are going to change a little bit. And when we accept that, you can see that the color map on the screen updates and the graphic updates as well. I'm just going to go back and change this back to continuous. And we'll accept that. So now what we can do on deviations is that we can toggle on a color map grid that just gives us kind of a random grid of points on the part, and that's a toggle, so we can turn that on and off. Another thing we can do is we can add Min and Max Annotations. So you can see here that this blue point here is the lowest point in the scan, and conversely on the high side it's red, so that's positive, so that means that the scan's sticking out. So I'm going to kind of just show you what that looks like here. I'm going to go ahead and turn my CAD on and also make it transparent so we can kind of get a good look at what that point looks like. So you can see here as I rotate the part, zoom up a little, you can see clearly that that point lies below the CAD surfaces there. So that's the low side. And then we'll go ahead and look on the right side here, on the high side. And it looks like there's a little bit of a spike there. So that could be erroneous data, or it could be that there's actually a little burr on the part. If this part was machined out of metal, maybe the deburring process wasn't done appropriately and there might be a little piece of metal sticking out. So in any case, I'd probably just look at the part to make sure that that is or is not the case and go from there. So after I've got the min and max, I can also add my own deviation tags just by clicking anywhere I want. So you can see I've got a high one there, a low one, maybe one here that looks like it's green, so it's within tolerance. And also you can see that the color swatches correlate to the color bar. So ultimately here I'm kind of setting up for a snapshot. So I just want to kind of get the part in a good orientation and rearrange my deviation tags here. So I get them kind of off the part and set up for my first snapshot. So you can see here now that the snapshot is in the tree. I'm going to go ahead and rename that. So I just double clicked on the snapshot. Basically why I'm doing that is I want to give it a name that's meaningful. So any name I give it here will be passed along to the report. So I'm going to change it from snapshot 1 to 3D deviations. Say OK. And now you can see on the tree here that it got updated with that name. I'll go ahead and turn my CAD back on. Okay, so the next step here is we want to create some entities for measuring linear, radial, and angular dimensions. So I'm going to go ahead and start. I think the first dimension I'm going to do is basically from the outside face to the other outside face. So that's going along the x-axis there. So I need to create a couple of planes. So the first plane here is going to be just pick on CAD, which is the default. What that allows me to do is simply pick on a CAD face, and then I get a nominal plane, which is the white plane, and then the measured plane is the yellow plane. So it creates planes for both CAD and measured, and it kind of creates a pair that will allow it to be analyzed. You can see here that it shows us the fit and the error distribution here, so it's pretty good fit. But let's say we had a burr here. We could, manually change it if we want, or simply by just clicking on shrink, we can shrink the data back from the edges there if we wanted to. You can see now that it kind of shrinks back a little bit. Just to go back, I'll hit grow, so it goes back to the original selection. So there are ways to adjust the fit if needed. So I'll accept plane number 1. It increments to plane number 2. So I'm going to repeat this process for the other side of the part. And again, you can see the pair of planes and the fit. Also notice here that in the dimension dialog box, I have nothing checked with respect to these planes. That's because I'm really creating these planes kind of for reference to create linear dimensions. So I'm not really interested in the planes themselves being reported. So even though they're created, there's nothing about them that's going to be included in the report. So at this point, I'm ready to add a distance or a dimension. The construction method is going to be from point to point. So I'm going to go ahead and pick my first point, which is going to be plane number 1, center. And then the second point will be plane number 2, center. And then you can see it adds a dimension here, a distance. But in the dimension dialog box, you can see here, it basically adds a kind of a 3D from center to center. And what I want to do is kind of constrain that to the x-axis because that's the dimension that we're taking. So what I'm going to do is turn off 3D and instead enable the x distance. And I can drag that out of the way. We'll go ahead and accept that. I'm going to repeat that process basically for the y direction. So I need to create a plane here on the back side of the part, but I'm going to do it a little bit differently. Instead of creating planes, I'm going to go ahead and create some points first, just to show you a different approach. So here, I'm just going to go ahead and create a point, selecting on the CAD, and you can see that there's kind of a sampling radius here, shown in green. If I want to make that a little bit smaller, I can control that radius by the calculation filter parameters and just kind of make that a little bit smaller value, let's say about 60 thousandths of an inch. And then you can see that the update occurs on the screen, a little bit less sampling. I'll go ahead and accept that. And for point number 2, I'm going to go ahead and repeat that process for this other opposite corner on this face. And then I want to repeat that process for the other side of the part. So point number 3, and then again point number 4. So I'm going to create 4 points first. And then the 5th point I'm going to create is basically going to be an average of these points. So I'm going to go ahead and say constructed, and the method is going to be average point selection. You can see I've got the 4 points here on the list. So I'm going to go ahead and select all 4 points. And then on the screen, you can see this gray point here. That's point number 5. To give it some meaning, so I can easily see it in a tree of entities, I'm going to go ahead and rename that to average point. It'll be easier to pick out if I need to see it. So that's my point. On the front side, I'm going to go ahead and create a plane. Like before, pick on CAD. So once that plane number 4 is created, I can go ahead and create another dimension. This time, I'm going to change it from point to point and plane. So my point is going to be the average point. My plane is going to be the last plane. Now I don't have to pick it off the list. Once it's on the screen, I can go ahead and just pick on the plane on the screen, and that will populate that field for me. Just like before, it defaults to 3D, so I need to change that In this case, I'll change it to the Y direction. At this point, I can also give it a name as I'm creating this dimension. So let's just give this a name, overall Y. You can see here it's called overall Y. Now, I kind of forgot to name the first dimension. So if you don't do it as you're creating it, you certainly can do it after the fact. So I'll go ahead and rename that first dimension to overall X. And we're going to create one more linear dimension here inside of this slot area. And again, I'm going to show kind of a different way to do it. So on plane number 4, instead of saying pick on CAD, which if you recall, it picks the entire face of the CAD, I'm going to say fit on points. And what that allows me to do is to pick discretely points that I want to make a plane with. So I'm going to go ahead and click on 4 spots on the nominal. And since we're doing it manually this way, then I need to repeat that process for the measured on the mesh. So I'm going to go ahead and pick a selection tool, and I'm going to go ahead and pick triangle picking. That will allow me to pick a single triangle. And I'm trying to pick spots close to where I picked before in the nominal. So I'll accept that. And then I'll repeat that on the other side of the slot here. So I'm just picking, it's almost like kind of a virtual probe, if you will. You can see the crosshairs and it looks like kind of a little probe. So again, I'm going to have to do that on the mesh as well. The other thing, just to kind of point it here, again, I'm not reporting anything about the planes, but in the plus or minus field here, it shows us kind of the range of error, plus or minus. So you can see that that number is a very small number. So that means that the planes paired together are a very close fit. So once I have the 2 planes created, go ahead and create another distance. And again, I'm going to go ahead and rename this from the beginning. I'll call it slot. And I'll just pick off the screen. So plane number 4 and then plane number 5 are the 2 planes I'm using. Again, I'm going to go ahead and change the values here, or uncheck 3D and constrain it to the X dimension. Okay, so after the 3 linear dimensions are created, maybe we want to create some cylinders, get some information about those. So I'll go ahead and pick cylinder. We're going to say pick on CAD. So we're just going to go ahead and pick on a CAD face. And zoom up on it a little bit here. And again, you can see the fit, the error distribution. So here, I'm not reporting anything except for the diameter. You can see the diameter is the only thing checked. And we have the XYZ information. Again, I'm not interested in it, but just to show you why it's flagging Z here with the red X's, it's because that the nominals of the measured and the CAD are opposite of each other. So I just need to flip one of the two. So I'll go ahead and flip measure. Now they're both going in the same direction, and you can see it cleared off any flags, in this case for the Z. So I'll go ahead and accept that. Let's create this other cylinder here. Looks like they're opposing again, so I just need to flip, in this case, the measured, and everything looks good. So I'll accept that. So for these up here, just again to show something different, let's say this part was sheet metal. I know it's not, but if you could pretend it was, it could be hard to fit a cylinder in a sheet metal hole just because the material thickness is very small. So instead, what we can do is we can treat these as a circle. So I'm going to go ahead and say, create a circle. I'm going to go ahead and pick on a CAD edge. And then underneath, it's finding the virtual edge of the circle on the mesh. So you can see the sampling in orange on the screen. So I'll go ahead and create another circle on this side. Same thing. So now we can, if we wanted to add a dimension between circles here. So I'm going to go ahead and pick the circle here on the screen, and you can see it gives us a drop down, and that's because there's kind of a plane superimposed on top of the circle. So it's kind of just letting us verify what we want to select. So I'm going to say from circle 2 to circle 1, change that to the X dimension. And accept that. So what I'm doing is setting up for a screenshot. So I'm going to go ahead and orient this so I'm looking straight down the Z axis. You can see here this little cube helps us determine the orientation. So what I'm doing is I'm going to go ahead and set up for a screenshot. So I want to turn off that plane. I don't really want that as part of the screenshot. So I just need to kind of reorder the dimensions in the way I want them to be displayed on the screenshot. So I'll go ahead and also rename this between circles. The reason I did that is so I can also add an entity annotation. So you can see when I snap on that, now it kind of gives us this frame with the name of the entity, and it gives us the dimension, the tolerances, the nominal, the measured, and what the deviation is. So once that's done, I'm going to go ahead and click on Snapshot. Again, I'm going to rename this snapshot. The reason I'm doing that is any name I give a snapshot will be passed along to the report. So I'll call that front view because we're looking straight down Z, so that would be the front view. The other thing I'm going to do is I'm going to basically everything I've created so far is in the front view. So I'm going to select all the entities that I've created and group them. That's just kind of another way to manage the data. If you do have multiple views like front, top, right, this is a way to kind of group things. And then of course I'm going to give it a name, front view. So the next thing we're going to look at is editing tolerances. So far I really haven't paid attention to the tolerances per se. I've left everything default, and in this case we're working in English. By default, the default tolerances are set plus or minus 39 thousandths of an inch. So here I'm just going to show you how to edit multiple tolerances at the same time. So we'll go ahead and look at how to edit tolerances after the fact. So I'm going to go ahead and expand the group. And I'm looking at all the dimensions. So it's overall X, overall Y, the slot dimension here, and between circles. So I can right mouse click on that and say edit. That's if I want to do a group edit. And you can see that X and Y are checked. That's because that so far is the only axes I've dimensioned. I haven't done anything in Z. So I can go ahead and change that. Let's change this to 5 thousandths of an inch. So that'll be plus or minus. And that's for the X. So I'll go ahead and repeat that for the Y. So now we've altered the tolerances here for all the entities that we've selected. You can see here now that I've done that even the entity annotation here gets updated as well. So it changed to plus or minus 5 thousandths of an inch. The next thing we might want to do is to go ahead and create a cross-section. So we can create cross-sections in a linear fashion, a radial fashion. We can create multiple cross-sections, but I'm just going to do a simple cross-section here. And let's say I want a cross-section through that hole and parallel to the coordinate system in the YZ direction. So I'm going to go ahead and say create a plane. It's going to be constructed because the plane's already there. And the construction method I'm going to say is plane offset through a point. So the plane, again, it's already in the session. It's going to be based on the coordinate system, the YZ plane, which you can see here, the Y is green and the Z is blue. So that's going to be my plane, and the offset is basically going to go through the circle number 2 center. So you can see it gives us a preview of that plane going through the center of the hole parallel to the YZ. And again, for housekeeping purposes, I'll go ahead and rename that cross-section plane. So once I have a plane established, I can go ahead and actually create the cross-section. It's going to be a single cross-section, and the existing plane is going to be the cross-section plane. Gives us a preview there. So once that's created, I may want to look at this. Of course, it's a cross-section, so I may want to look at this in more of a 2D view. So I'll click on 2D view, and it puts us kind of in this grid orientation, and I'm going to go ahead and just rotate that clockwise 90 degrees. You can see here that we have some color. This is similar to the color map, except for we're looking at a cross-section. You can see here we've got some high, blue, low, and then width and tolerance. We can also change the magnification of the whiskers. So we can go pretty excessive. That might be a little bit hard to see or look at in the report. So I'm going to kind of back it off until I get a good magnification that I can see. At this point, like before, we can add our deviation annotations. So I'm just going to kind of just pick a couple of spots here that we might want to look at in the report. The other thing here, ultimately, what I'm going to do is create an angular dimension. So before I do that, I need to create a couple of lines first. So what I'm going to do here is use a selection tool. It's going to be similar normal. So wherever I pick, it's going to pick the geometry next to it that's has the same normal. So you can see it kind of fit a line on that segment there. So that's line number 1. And line number 2, I'm just going to again pick on a little line segment here, and I'm going to add a second one and a third one to basically get the entire range of that plane. And once I have the 2 lines created, I'm going to say it's going to be line-to-line method. I'm looking for an acute angle. I'm going to go ahead and pick line number 1. And then I'm going to go ahead and pick line number 2. And you can see it gives us an angle here. Looks like the nominal was 6.5. Measured is 6.579. I'm going to go ahead and maybe change the tolerance here. Let's tighten it up a little bit, 0.5. And you can see it passes. It shows us the deviation here. So I'll go ahead and accept that. And once we back out, you can see it goes back to the cross-section with the annotations here. So I'm going to go ahead and take a snapshot. And again, give it a name. Cross-section. So here I'm going to turn all the entities off, because what I want to do ultimately here is to create a screenshot or snapshot for my report that just shows the part itself, just shows the CAD. So I'm going to get to an orientation I like, go ahead and click on snapshot. And again, I'm going to go ahead and rename it. I'm also going to say show in front page. That's going to force this snapshot to be the first thing in the report. So I'm going to go ahead and give it a name, and I'll just go ahead and name it the part name is. So I'm going to call this arrow bracket. Once that's created, now I'm ready to go ahead and go to the next step. So finally, we're going to go ahead and generate an inspection report. So with all my inspection sequence done, I'm going to go ahead and create an inspection report. So just click on the report. And you can see I've got project information, part information. Anywhere it says click to edit, I can go ahead and edit that field. In this case, I'm going to give the part name its name. If I want to, I can add my initials here. I can also reorder all these fields here as well. So let's give it a part number. Let's say 1, 2, 3, 4. And once everything's filled out to your liking, you can go ahead and say export. And it's going to open up Windows Explorer and have us give it a name. You can pick the path you want. So I'll go ahead and say save. Again, it's looking at the inspection sequence and propagating all that information over to Excel. And once it's done, it opens up Excel automatically. And you can see here the project information, all the stuff that we gave names to shows up. Our first screenshot here, the arrow bracket, showing the CAD. Our next screenshot is the 3D deviations that we created. And with the individual points that we have as far as the annotations, we can see the nominal, the measured. If something was out of tolerance, there would be a red X here, but so far there's nothing really out of tolerance. So we're going to just keep looking down here and see that we have our front view, and our last thing was the cross section. And you can see here that we have our angle showing us our dimensions and whether or not it's within tolerance. So that's about it for the software. It's very easy to use. You can see that we created an inspection sequence. So basically, in summary, what we did was we created an inspection sequence by adding an alignment, creating geometric entities, deviation maps, snapshots, and more. We created basic dimensions, which measured the scan mesh part to CAD nominal. Lastly, we created an inspection report from the inspection sequence and output to a Microsoft Excel file. Thank you very much for attending today's presentation. Bye-bye for now.